Why do some salts dissolve in water while others settle as a residue? That simple difference shapes everything, from our bodies to our industries. Solubility is one of the most important chemical properties of salts. It determines whether a salt will dissolve in water and affects how it participates in chemical reactions, biological functions, and industrial applications. Solubility depends mainly on the balance between two energies: the energy required to break the ionic lattice of the salt and the energy released when ions get hydrated by water. It is also influenced by factors like temperature and the presence of other dissolved ions. Understanding these influences gives us power to predict and control salt behavior in different environments. From table salt in your kitchen to the electrolytes in your body, many salts dissolve effortlessly in water. Soluble salts dissolve readily, releasing ions into solution. All nitrates, such as sodium nitrate and potassium nitrate, are soluble. Most chlorides, bromides, and iodides are also soluble, but silver, lead, and mercury, salts are notable exceptions. Sulfates are generally soluble too, although barium sulfate, lead sulfate, and calcium sulfate are exceptions to remember. These soluble salts are crucial in biology, medicine, and industry, especially as electrolytes in batteries, cells, and solutions. Not everything that meets water dissolves in it. Some salts are practically stubborn, they remain solid and form precipitates. These are the insoluble salts, which include most carbonates, phosphates, and sulfides, except those of alkali metals and ammonium. Examples include lead, sulfate, and barium sulfate. These salts often appear as precipitates during double decomposition reactions. Insoluble salts are widely used, from ceramics and pigments to wastewater treatment, where their low solubility becomes an advantage. Some salts sit in between, not fully soluble, not fully insoluble. They dissolve just a little and leave the rest behind. These are the slightly soluble salts or sparingly soluble salts. They form saturated solutions where undissolved solid remains. Common examples are calcium hydroxide and silver chloride. Their behavior is governed by the solubility product, or KSP, a fixed value at a given temperature. These salts are key to understanding chemical equilibria and are often used in qualitative analysis in labs. Need to know if a salt is soluble? There's no need to memorize hundreds of compounds, just remember a few powerful rules. All nitrates and alkali metal salts are always soluble. Most chlorides, bromides, and iodides are soluble except when they contain silver, lead, or mercury, Sulfates are usually soluble except for those with barium, lead, or calcium. On the other hand, most carbonates, phosphates, and hydroxides are insoluble unless they're paired with alkali metals or ammonium. These quick rules let chemists predict solubility in seconds, saving time and guiding lab decisions. Why does solubility matter in real life? Because it influences how we clean water, deliver medicine, and protect the environment. Knowing whether a salt is soluble helps us predict precipitate formation, design purification methods, and perform accurate chemical tests. In pharmaceuticals, solubility determines how drugs are formulated and absorbed in the body. In environmental science, solubility tells us how salts move through soil and water, affecting agriculture and water quality. In short, solubility is not just a textbook topic, it's a practical guide to making chemistry work for people and the planet. Let's summarize what we've learned about the solubility of salts. Solubility depends on several factors, including lattice energy, hydration energy, temperature, and the presence of other ions in the solution. Some salts are highly soluble. For example, all nitrates and most chlorides, bromides, and iodides except those of silver, lead, and mercury. Similarly, most sulfates are soluble except barium, lead, and calcium sulfates. On the other hand, salts like carbonates, phosphates, hydroxides, and sulfides are generally insoluble, except for those of alkali metals and ammonium. There are also slightly soluble salts such as calcium hydroxide or silver chloride, whose solubility depends on equilibrium and Ksp values. Understanding solubility rules helps us predict reaction outcomes, purify chemical substances, and evaluate environmental impact, especially in water systems.